Beneath Vancouver's tranquil coastline, where the city meets the endless blue of the Pacific, a hidden world stirs with quiet intensity. While the surface appears calm and serene, a powerful geological drama is quietly intensifying far below. The ground beneath our feet is not as solid as it seems. It's a living, shifting foundation, shaped by forces that have been at work for millions of years. Geologists have detected a persistent shift in the Earth's behavior, a subtle, almost imperceptible hum of activity emanating from the Cascadia Subduction Zone, a region infamous for its seismic potential. This isn't a sudden catastrophe, at least not yet. Instead, it's a slow, relentless buildup of tectonic pressure, as if the Earth itself is taking a deep breath and holding it. Recent data shows an increase in episodic tremor and slip events, slow, silent movements where one plate slides past another, releasing energy without the violence of a typical earthquake. These tremors are critical indicators of stress accumulating along the locked megathrust fault, a vast underground boundary where a future great earthquake is expected to originate. The Juan de Fuca plate is relentlessly pushing beneath the North American plate, inch by inch, storing energy like a colossal spring wound ever tighter with each passing year. The recent uptick in deep tremors suggests this spring is being wound tighter than ever before, prompting scientists to reevaluate seismic hazard models and reconsider the risks facing the region. Vancouver, perched above this dynamic and unpredictable fault, faces a precarious balance between the beauty of its landscape and the dangers lurking below. The findings don't predict imminent disaster, but they do shorten the odds and shrink the timeline, reminding us that the next big event could be closer than we think. The ground beneath Vancouver is more alive than ever, a message from the restless Earth, one we can no longer afford to ignore. To truly grasp the scale and urgency of this change, we need to look beyond what we see on the surface. We turn to the data, hard numbers and real-time measurements that reveal the hidden story unfolding beneath our feet. Modern seismology listens to the Earth's faintest whispers through a vast network of GPS stations and ultra-sensitive seismometers spread across the Pacific Northwest, each one acting as a sentinel for the planet's restless crust. These instruments are so precise, they can detect ground movements as small as a few millimeters, movements invisible to the naked eye, but crucial for understanding what's happening below. Over the last 2 years, the data shows Vancouver Island has not only bulged upward, but also shifted westward at an accelerated rate, especially during tremor events. This is not a subtle change. It's a measurable, significant shift in the landscape. Time-lapse maps and animated graphs reveal a dramatic increase in both the frequency and energy of slow slip events since early 2024, painting a picture of a region in motion. These visualizations pinpoint clusters of intense tremors occurring 30 to 40 kilometers beneath Vancouver Island and the Strait of Georgia, deep underground, where tectonic plates grind and strain. This transitional zone is where immense geological stress is being transferred upward, gradually loading the fault segment known to produce catastrophic megathrust earthquakes. Dr. Pascal Lavoie of the Geological Survey of Canada notes, "This is a change in the character of the subduction zone's behavior. The system is becoming more active." His words echo the growing concern among scientists. While we can't predict the exact moment a major earthquake will strike, the data is clear. The geological processes beneath Vancouver Island are accelerating, and the risk is rising. We are, in essence, watching the fuse burn. And it's burning faster than before. The countdown is no longer theoretical. It's visible in the numbers. The data transforms what was once an abstract risk into a clear, urgent warning for everyone living in the region. The Earth's vital signs are unmistakable, pulsing with the energy of a system under strain. The region's future is being written in real time, moment by moment, as the data continues to stream in, reminding us that the story is far from over. To understand Vancouver's risk, we must first understand the Cascadia Subduction Zone. Here, the oceanic Juan de Fuca plate dives beneath the North American plate, a collision that builds mountains, fuels volcanoes, and shapes the Pacific Northwest. The Cascadia Subduction Zone stretches 1,000 kilometers from Northern California to Vancouver Island. Subduction zones produce the world's largest earthquakes, megathrust events, when locked plates suddenly snap apart, releasing centuries of stored energy. The last great Cascadia earthquake struck in 1700, confirmed by geological evidence and Japanese tsunami records. That event, estimated at magnitude 9.0, is a stark reminder of Cascadia's potential. The geological clock has been ticking ever since, with strain building year by year. The next rupture is a matter of when, not if. Vancouver's unique geology amplifies its seismic risk. Much of the city sits atop soft, water-saturated sediments of the Fraser River Delta, which can amplify shaking and trigger liquefaction during an earthquake. Buildings may tilt, underground pipes can rupture, and the ground itself may crack and spread. The subducting plate beneath Vancouver is unusually shallow, bringing the locked fault closer to the surface and intensifying ground motion. This combination, a shallow rupture and amplifying sediments, creates a double-edged sword of seismic hazard. Recent deep tremors are a direct indicator of mounting stress on the locked fault. Vancouver's geology not only increases vulnerability, but also provides a clearer warning of the danger ahead. The recent surge in tectonic activity is more than just a series of random tremors. It's a message from deep within the Earth, a subtle but urgent signal that something significant is unfolding beneath our feet. These movements originate far below the surface, where immense forces are constantly at work, shaping the landscape over millennia. Heightened episodic tremor and slip, known as ETS, are now being detected with increasing frequency, capturing the attention of scientists worldwide. These signals indicate changing stress conditions along the fault. One leading hypothesis suggests that increased fluid pressure at the plate boundary acts as a lubricant, making it easier for slow slip events to occur and for the plates to move past each other. This process can alter the friction in the locked zone, where stress builds up over time. Each slow slip event silently redistributes stress, gradually loading the fault above and increasing the potential for a larger rupture. The intensification of ETS means this process is accelerating, with more frequent and intense tremors being recorded than ever before. This escalation brings the entire tectonic system closer to a critical point, closer to failure, where a major earthquake could be triggered. The Pacific Northwest Seismic Network has issued a clear statement. The subduction zone has entered a more dynamic phase, they warn, highlighting the increased risk. History reminds us that a great earthquake in this region is not just possible, it is inevitable. GPS and seismic data now show a measurable and growing increase in strain accumulation, confirming that the ground is under mounting pressure. While short-term prediction of exactly when an earthquake will strike isn't possible, the urgency for preparedness is clear. Communities must take these warnings seriously and ensure they are ready for what may come. The system is now behaving in ways that are eerily similar to patterns observed before major failures in the past. The Earth's signals are growing louder and more insistent, demanding our full attention and respect. The big one, a magnitude 9.0 megathrust earthquake, would devastate Vancouver. Prolonged, violent shaking could last up to 5 minutes, toppling older buildings and damaging infrastructure. Minutes later, a tsunami would threaten low-lying communities, compounding destruction. Liquefaction in the Fraser Delta would rupture utilities, spark fires, and cripple emergency response. Bridges and tunnels could fail, isolating neighborhoods and hampering recovery. Scientific models predict weeks of power outages, communication breakdowns, and a long, arduous recovery. The big one would fundamentally reshape the region for generations. Intensified tectonic activity beneath Vancouver also raises volcanic risks. Subduction feeds the Cascade volcanoes, including Mount Baker, by generating magma deep underground. A major earthquake can jolt magma chambers, potentially triggering eruptions or opening new pathways for magma. Mount Baker, just 110 kilometers from Vancouver, poses a significant threat. An eruption could send ash clouds over the city and disrupt aviation. While Vancouver isn't in the direct path of volcanic mudflows, ash could cause respiratory problems and widespread disruption. The recent tremors are a symptom of a more active subduction process, loading both faults and magma chambers. The region must consider both earthquake and volcanic hazards in its planning, In response, Vancouver is taking action to build resilience. Governments and engineers are retrofitting schools, hospitals, and bridges to withstand intense shaking. Strict building codes now guide new construction, but many older buildings remain vulnerable. Public education campaigns encourage emergency preparedness and self-sufficiency. Municipal plans coordinate first responders, shelters, and tsunami warnings. The recent uptick in tectonic activity has added urgency to these efforts. Preparedness is now a community-wide priority. The story of Vancouver's subduction zone is written in stone and time. Recent data confirms the Cascadia Fault is active and accumulating stress at an accelerated rate. The big one is not a question of if, but when. This understanding transforms a theoretical hazard into a clear and present reality. Vancouver's unique geology and interconnected risks demand vigilance and action. Through engineering, planning, and education, the community is racing to prepare. Each tremor refines our understanding and urgency. The final chapter is unwritten. Will we be ready when the page turns?